I'm John Guttag. I'm a professor of electrical engineering and computer science, mostly computer science at MIT. I have been at MIT for a long time, taught a lot of different things, but my most satisfying teaching experience has been introductory computer science, programming, and data science. Uh, the book is now in its third edition. It was based upon a fairly complicated experience that I think in 2004, I taught a brand new introductory computer science course to a whopping 5 students enrolled for the class. And my idea was to approach it not from the point of view of a computer scientist, but from the point of view of someone who might want to use computing to do something else. And at the time, that was a different introductory course, certainly for our department, where our introductory course was aimed primarily at majors. This was intended to be aimed primarily at people who at least didn't know that they would want to major in computer science, would probably major in something else, but my hope was some number would fall in love with computer science and do that anyway. Over the years, it has developed. This year, I will assign about 1,000 grades to MIT students for this course. And to put that in perspective, MIT has between 1,100 and 1,200 freshmen a year. So to be assigning 1,000 grades is a lot of students, a large fraction of MIT. We then produced an OpenCourseWare version of it, which was extremely successful. To date, well over 2 million people have taken it. And it's nice in that it's asynchronous, so people can take it in their own time. We have a lot of people who really don't have time to be full-time students, but can put in a few hours a week learning something new. And for them, OpenCourseWare is ideal. We've done 3 different versions of the OpenCourseWare, and we're probably due now to do another version with the new set of lectures. We then introduced a synchronous version on MITx, or I guess edX platform. It's different in that things are timed. And so students have to submit and get problem sets graded on a schedule. And again, for a lot of people, that also works better because it's the discipline of a schedule helps people stick with things. And also they can get a certificate at the end because there are exams, there are problem sets, they're all graded. That too has been quite successful. Again, over 2 million learners have used that platform in addition to the separate over 2 million who've used OpenCourseWare. So I've been very pleased. And of course, I should be careful to say I didn't do this alone. I had a lot of help with the online versions, particularly from Annabelle and Eric Grimson. And without the two of them, these online courses would never have happened. So they are entitled to lots of credit for that. The online courses taught us something. We got a lot of complaints in the beginning that people could commit to 6 or 8 weeks. They couldn't commit to 13 or 14 weeks in a course because, as they would say, life happens. And so that prompted us to split the online course into 2 halves. It worked so well that we decided to do the same thing at MIT. It's one of those interesting things where usually we think we move from MIT to online. Here we move from online to MIT. And we split it into 2 half-term courses. The first half is essentially an introduction to programming and computer science. And the second half is an introduction to computational modeling and data science. Unsurprisingly, about 300 students a year take an advanced standing exam and place out of the first course and jump right into the second course, which has been one advantage of splitting it. Another advantage is some people take one course and that's enough. But at MIT, it's been the case that the vast majority of students take both one after another, the two half-term subjects. That led me to rethink the structure of the book and said, well, if this book is not to be used for one subject, but for two, and my guess is probably it would have been better off using it for 3 subjects, given how rather long it is. It's probably doubled in size from the first edition. Not necessarily a good thing, but a fact. And that, the 3rd edition in particular, I worked hard at modularizing things so that people who want to cover different subsets of the material can do that in a way that won't have the students forever saying, oh, but I didn't read chapter 8. Now I'm confused in chapter 10. Now, there is probably you do need to read chapter 8. I chose a bad example, right? That there's a beginning part you need to come up to speed on. And that's, if you don't know Python at all, you really have to go through the introductory chapters and get to a certain level of programming. You may not need all of the advanced concepts, which get presented later in the book. But once you're through that, then an instructor can say, well, all right, what I'm really interested in is data science. And so now let me focus on the chapters that relate to statistics, to managing data. And I really don't need to talk about simulation models. Another instructor might say, well, most of my students are going to go on into the sciences, and it's very important that they understand how to build simulations and how to understand simulations. And it's very important they understand how to deal with randomness in computation. So I'm going to focus on those chapters. So it was an effort, but I'm glad I did it, to try and structure things in a way that people can find their own way through assembling half semester courses, full semester courses, or probably you could even put together 2 full semester introductory courses out of the material in the book now. But I wanted to do that. I teach a course once or twice a year from this book at MIT. And every time I teach it, I want to use current examples, say, in the lectures. So for example, there's a chapter on misuse of statistics. Every term, I can open the newspaper and get 12 examples from that week of somebody, usually in Washington, D.C., misusing statistics. I figured as long as I have the modern examples in my lectures, I might as well update the book to have the more contemporary examples, not because they teach the concepts better, but because they're more fun for a reader. Similarly, I introduced a new simulation. Simulation plays a theme in the book. And I introduced a simulation on how a virus spreads, not within a body, but within a society. And that was part of a new section on interactive plotting. And so there's a section on, okay, what happens if you move this slider to change the amount of social distancing enforced? What effect does that have on the number of people who become infected? And again, it's an interesting concurrent example. You can play it and you can see, well, now I understand why this state is having more cases than that state, maybe. And again, it's a contemporary example, but also this was the first time the book has had interactive plotting in it. And again, that was prompted by my realizing that I was enjoying the interactive plots I could use online to play these what if games. So I figured, why not teach the students how to do interactive plots? So that was what was nice, and updating things. What other changes did I make? Oh, probably the most important change is I proceed much more slowly through the introductory material. I got a lot of feedback from users that, well, maybe this is an appropriate pace for some students, but not for all of my students. And it's even true at MIT. It's an appropriate pace for some students, but not for all students. And so the introductory chapters proceed more slowly. I introduce the material, I won't say more carefully, but with more examples than I used to have. There's a little bit more repetition to help the learner. And so the introductory chapters have just expanded as I've tried to slow down the pace and make it easier for a novice to follow. And for a lot of people, that will probably be the most meaningful change. And I hope it helps make it more digestible. Along the same lines, I've introduced a lot more finger exercises. So I've gone to out of my way to not get very far in a new concept before I stop and say, this should take you about 10 minutes to do, try this exercise. And it will help you see whether you really understand what you just read or don't. One use of the book is as a textbook for an introductory course on data science. Today, almost anyone who does data science in Python uses what's called pandas. It's a library. It's not about the cute little animal, or actually it's not so little animal. It's about the cute animal. It's not about that. It's a set of tools for processing data, doing simple data manipulation, storing data in a convenient format. And in the previous edition, I did all those things in raw Python, just writing the code myself for it. But I realized that's not what people should be doing in practice. They should be using this library that's already there. And so it's quite a lengthy chapter because Pandas has a lot of facilities. And it's by no means a comprehensive introduction to Pandas. People write books on Pandas. But it is enough that it can get people started and pretty far along in using it to just make it easier to do some of the grunge work in managing data. And I just decided it was important to include that in the book. I think a lot of people will probably not end up teaching Pandas in their course, but will want to be able to point the students at the chapter and say, if you're going to actually find yourself manipulating data, I suggest you read this chapter, and it'll get you off to a good start. It's something I'm very proud of the fact that the book has been widely adopted, ranging from community colleges to elite engineering schools. And it was something I wanted from the beginning, that I don't want this to be, computer science shouldn't belong to a small elite class. And it certainly shouldn't belong only to people who've had privileged backgrounds in high school that allowed them to get a head start. A lot of the students at community colleges are every bit as good as the students at MIT. They just didn't have the same advantages growing up. And so I think it's really important that it be widely accessible. And I get a surprisingly large number of emails from middle school students and parents of middle school students saying, you know, we were trapped at home during the pandemic, and I gave the book to my 12-year-old who really had fun. and I get a kick out of that. I also get a kick out of the emails I get from 80-year-olds who say, you know, I impressed the heck out of my grandkid that I can program. You know, these are often retired engineers who didn't grow up in an era where you learned to program. And they said, you know, I'm retired. I was looking for something to do. I decided I'd learn to code, and it was fun, and I really enjoyed it. And my grandchildren are super impressed. And it's one of the nice things about writing a book that gets widely used is you get to really feel good about touching people's lives. I feel the same way about the online courses on edX, that I get these emails that really make me just feel wonderful about the ability to help people and change lives with a field I love.